Breaking news. Moments ago at precisely 0218 UTC, a secure data packet left the James Webb Space Telescope and arrived simultaneously at mission control centers in Maryland, Darmstadt, and Canberra. Within seconds, alarms that were never meant to sound during routine observation cycles activated across 3 continents. Today, the impossible just happened. An object we believed we understood, an interstellar visitor cataloged as 3I Atlas, did something no model, no simulation, and no known law of physics had predicted. What James Webb recorded in the mid-infrared spectrum does not resemble a comet, an asteroid, or any naturally occurring interstellar body ever observed. This changes everything we thought we knew about what moves between the stars. If you want real-time updates on the biggest cosmic mysteries unfolding right now, make sure you like this video, subscribe, and stay with us, because this story is still developing. Within minutes of the alert, internal communication channels lit up at NASA and ESA. Data streams were locked. Secondary verification protocols were initiated. The observation was real, and once confirmed, the question was no longer what are we seeing, but why has it never happened before, until now. The authority behind this moment matters. The James Webb Space Telescope is not a speculative instrument. It is the most powerful space observatory ever built, operating at the second Lagrange point, 1.5 million kilometers from Earth. Its instruments, NIRSpec, NIRCam, and MIRI, can resolve chemical signatures, temperature gradients, and structural details at distances measured in light years. The observation of 3I Atlas was not isolated. It was coordinated. Hubble was simultaneously tracking visible light reflectivity from low Earth orbit. The Atacama Large Millimeter Submillimeter Array in Chile was monitoring submillimeter emissions from the southern hemisphere. Ground-based optical arrays in Hawaii and the Canary Islands provided astrometric confirmation. Across North America, Europe, and South America, the same conclusion emerged independently. Something about 3I Atlas had changed. For months, 3I Atlas had been considered anomalous but not unprecedented. Discovered on a hyperbolic trajectory with an inbound velocity of 42 kilometers per second relative to the Sun, it was clearly interstellar. Its perihelion distance placed it just inside the orbit of Mars at 1.27 astronomical units. Spectroscopy suggested a volatile pore composition, unusual for a comet but not impossible, until now. 48 hours before the Webb event, routine trajectory refinements began showing subtle inconsistencies. Orbital residuals, normally within a few milliarcseconds, began to drift. At first, analysts attributed the deviation to outgassing asymmetry or solar radiation pressure. 11 hours later, those explanations no longer fit. The acceleration vector was wrong. It wasn't aligned with the Sun. It wasn't random. It was precise. At 1942 UTC, Webb's MIRI instrument began a scheduled deep scan across the 7 to 21 micron band. The surface temperature of 3I Atlas, expected to be around 180 Kelvin at its heliocentric distance, instead displayed sharp thermal gradients, regions spiking to 310 Kelvin adjacent to zones below 120 Kelvin. No natural rotational model could account for such contrast. Then came the shape data. Infrared occultation analysis revealed edges, not irregular fractal edges typical of rubble piles, but smooth boundaries, symmetry. The object's effective cross-section oscillated between 2 stable values at an interval of exactly 11.46 minutes. That number mattered. It was too clean, too repeatable. 6 hours later, something else appeared. A narrow-band emission spike at 4.3 microns, carbon dioxide, followed by an unexpected suppression. Then, silence. No coma, no tail, no debris, just controlled behavior. This was when the internal discussions changed tone.
At Caltech, Dr. Eleanor Voss reran the gravitational perturbation models using updated mass estimates. The numbers collapsed. If the observed acceleration was correct, the inferred mass of 3I Atlas had to be far lower than previously calculated, by nearly 2 orders of magnitude. Either 90% of its mass had vanished, or it had never been there to begin with. At Harvard, Dr. Samuel Klein compared the spectral data against every known cometary class. Nothing matched. At ESA's Operations Center, engineers quietly noted that the object's thermal regulation resembled active heat dissipation, not passive solar absorption. Then, at 0311 UTC, Webb recorded what would become the most debated data frame of the mission so far: a pulse. Not a flare, not an explosion, a pulse of electromagnetic radiation centered at 1.42 gigahertz, the hydrogen line, the most fundamental frequency in astrophysics. The pulse repeated, once, twice, then again. The intervals were not random. They followed a sequence: 2 seconds, 3 seconds, 5 seconds, 7 seconds. Prime numbers. This was no longer an observation, it was an event. Internal alerts escalated to level red. Data access was restricted. Yet, as often happens, fragments leaked, enough to confirm that the object was not passively emitting, it was doing something. The scientific community fractured almost immediately. One group argued for an exotic natural explanation. Dr. Marcus Hale of the European Space Network proposed that 3I Atlas could be a fragment of a larger interstellar body composed of layered ices and metallic inclusions, undergoing phase transitions triggered by solar magnetic reconnection events. The pulses, he argued, could be magneto-hydrodynamic resonances. Rare, yes. Impossible, no. Others disagreed.
Dr. Lena Moretti, running computational simulations at CERN's Astrophysics division, pointed out that no known natural process could generate prime-numbered pulse intervals without fine-tuned initial conditions. Her models showed that even under extreme assumptions, stochastic processes dominated. Precision did not emerge spontaneously. As debates intensified, a second wave of anomalies arrived. 21 hours after the initial pulse, one of the secondary fragments, previously assumed to be a brightness artifact, vanished. Not dimmed, vanished. Hubble lost it first, then ground-based radar, then Webb itself. No debris field, no thermal spike. It simply ceased to exist within observable parameters. At the same moment, Earth-based magnetometers recorded a localized disturbance, not a storm, a ripple, a 0.7 nanotesla deviation synchronized across stations in Alaska, Finland, and New Zealand. Subtle, but real. Inside mission control rooms, no one spoke. Encrypted communications between agencies increased. Public statements remained cautious. Further analysis required. No confirmed conclusions. Yet internally, a phrase began appearing in private logs: responsive behavior. This was no longer random. It was responding. As days passed, the object's trajectory adjusted again, minutely but unmistakably. Its new vector reduced its outbound velocity relative to Earth by 0.03 kilometers per second. Insignificant by cosmic standards, intentional by any other. Philosophers were not consulted, engineers were. Could a non-biological system survive interstellar travel? Could it regulate heat, shed mass, emit signals, and alter course with minimal energy expenditure? The equations said yes, if designed. But designed by whom? The question hung in the air as data continued to arrive. Webb's final scheduled observation window captured one last detail: a geometric pattern in polarized light scattering. Not perfect, but close enough to unsettle everyone who saw it. In control rooms across the world, the realization settled quietly. Maybe we're not witnessing the end of something. Maybe this is the beginning.
I remember staring at the data feed as the last transmission came in. The room was silent, not from fear, but from awe. For centuries, humanity has looked outward, assuming the universe was indifferent, cold, random. But 3i Atlas does not feel random. It feels deliberate. Governments have not confirmed anything. Agencies have not denied anything. Satellites continue to function, mostly. Migratory patterns have shown minor deviations. Radio astronomers report intermittent noise floors where none existed before. Nothing catastrophic, nothing reassuring, just enough to remind us that we are not alone in our curiosity. As we stand on this threshold, one thought becomes unavoidable. If something can cross the void between stars, observe us without announcement, and leave without explanation, then our place in the universe is far less isolated than we once believed. Maybe we're not witnessing the end of something. Maybe this is the beginning. Or maybe this was just a probe. The last data point from James Webb shows 3i Atlas rotating slowly, its emission signature fading into the cosmic background. Its trajectory now points back toward interstellar space, for now. But the final question remains: what happens if it changes its mind? Subscribe to follow the next update. This story isn't over.